Welcome all. Today we will see the versatile nature of carbon. Versatile nature means it has many different properties. इसके बहुत सारे गुण हैं, अनेक गुण हैं इसके. So the first important property is that it makes largest number of compounds. So carbon is an element. It's a non-metal. Its symbol is C and it is the first element of group 14 of the periodic table. It is derived from the Latin word carbo. Carbo means coal. Hence, the carbon is the main constituent of coal. The amount of carbon which is present in our earth crust and atmosphere is also very small. Then also it has lot of importance. The food we eat, the clothes we wear, the cosmetics we use, petrol, natural gas, all are the compounds of carbon atoms. All living things, plants, animals, these all are made up of carbon only. So the compounds which are made up of carbon are known as organic compounds. Carbohydrates, then proteins, lipids, vitamins, synthetic fibers, plastics. These all contains carbon only. So these all are the compounds of carbon. Hence, carbon has a very special important property. It makes large number of compounds. So, J.J. Burgillis, a scientist, he named the compound that derived from living organisms as organic compound. So, according to him, the compounds which are obtained from the living organisms, they are known as organic compounds, and the compounds which are obtained from non-living organisms are called as the inorganic compounds. So this was told by Berzelius. According to him, he thought that a vital force is necessary to synthesize the organic compound. But his own student, that is Friedrich Hohler. Friedrich Hohler in 1828, he disapproved the vital force theory and he has prepared the first organic compound, urea, from the inorganic salt, that is the ammonium cyanate. So ammonium cyanate, he has prepared the first organic compound, urea, from ammonium cyanate. So ammonium cyanate is NH4CNO. On heating this compound, he prepared the urea. So this is the formula of urea. So CO, NH2, this is CO, NH2 twice. This is urea. It is the first organic compound synthesized in the laboratory from inorganic salt ammonium cyanate. So he also discovered that both ammonium cyanate and urea, they have the same chemical formula. But they have different chemical properties. So they have same chemical formula, but they have different properties. So this led to the discovery of isomerism. So you can see isomerism. I have already made one video on this. You can go through that video. The next important property of the carbon is that it forms covalent bonds. So carbon, the atomic number of carbon is 6, means that is the number of protons which is present inside the nucleus, and its electronic configuration is 1s2, 2s2, 2p2, or we can also write in K shell it has 2 electrons and in L shell it has 4 electrons. So this is a K shell, it has 2 electrons, and L shell it has 4 electrons. So K shell can accommodate maximum of 2 electrons, L shell can accommodate maximum of 8 electrons. So hence we can say carbon has 4 electrons in the outermost shell, that is the valence shell. So it should either gain 4 electrons or it should lose 4 electrons to attain the inert gas electronic configuration and become stable. So suppose carbon, if it loses 4 electrons, then it will form C4 plus ions. But carbon cannot lose 4 electrons to form C4 ions because carbon atom is very small. So it is very small and the outermost electrons are tightly held by the nucleus. So these outermost electrons, these are tightly held by the nucleus. So so to remove outermost electrons, it requires a huge amount of energy, which is not available normally. So therefore, C4 formation is not possible to attain inert gas configuration. Now, the carbon cannot gain 4 electrons to form C4 minus ion. It cannot gain also to attain the inert gas configuration. Why? Why? Because the electronegativity of carbon is only 2.5 and its nucleus has how many protons? Its nucleus has 6 protons. Therefore, it would be difficult for a nucleus with 6 protons to hold 10 electrons. See here, carbon has 6 electrons. If it forms C4 minus ion, then it will have 10 electrons. So it's very difficult for the nucleus with 6 protons to hold 10 electrons. So hence carbon cannot form C4 minus ions to attain inert gas configuration. So we have seen it can neither lose electrons nor it can gain electrons. So what now carbon will do? So it has only option that it will share its electrons. So it will share all its 4 electrons to attain the stable electronic configuration of octet in the outermost shell. So carbon will share its electrons with other atoms through the bond, and that bond is known as a covalent bond. Let's see one example in methane. So carbon has 4 electrons in the outermost shell and hydrogen has 1 electron. So it will share its electron with hydrogen. Again, it will share its electron with hydrogen, with hydrogen, with hydrogen. So these bonds are formed by sharing of electrons. Since these bonds are formed by sharing of electrons, so this type of bond is known as covalent bond. Now you see how many total electrons carbon has. 1, 2, 3, 4, 5, 6, 7, 8. Hence by sharing of electrons, carbon has attained the stable electronic configuration of octet. So now it's become stable. So these covalent bonds are formed by sharing of electrons and these covalent bonds are very strong bonds. So they will not easily break these bonds. So we can see another example also, like carbon can also form double bonds also. These also double bonds CC linkage. These also bonds are formed by the sharing of electrons. Again, they have the double bond and the single bond. These all bonds are formed by the sharing of electrons. That is why these all bonds are covalent bonds. In triple bond also, like in ethine, Ethine contains CC triple bond and CH single bond. So these all bonds are covalent bonds. In ethene also, the double bond and single bond all are covalent bonds. So these all bonds are formed by sharing of electrons and they are very strong bonds. So this is one of the important property of carbon to form covalent bond, and these bonds are very strong bonds. Next important property of carbon is tetravalency. So carbon, as we have seen that it has 4 electrons. It has 4 valence electrons. 4 valence electrons in the outermost shell, or that is also known as in the valence shell. So it requires 4 more electrons to attain stable inert gas electronic configuration of 8 electron in the outermost shell. So it gets 4 more electron by sharing. Therefore, valency of carbon is 4. Hence, we can say what? Carbon is tetravalent. And it is represented by this, like this. The bonds are represented by. So it is capable of bonding with 4 other atoms of carbon or monovalent atoms. So the bond formed by carbon are very strong due to its small size. And this enables the nucleus to hold the shared pair of electrons tightly, strongly. So carbon is tetravalent in nature because it has 4 valence electrons. Next important property of carbon is catenation. What is catenation? It is the self-linkage property of carbon. It means that carbon will make bond with another carbon. Again, that carbon will make another bond with another carbon. So in this way, it will form long chains of carbon. So one carbon will form bond with another carbon. Again, this will form bond with another carbon. Again, it will form bond with another carbon. Like this, we will get long chains of carbon atom. And these long chains give rise to what it will give rise to? It will give rise to large number of organic compounds. So the bonds formed by them, again, these are also covalent bonds. And covalent bonds are very strong bonds. They are very strong bonds. It means they will not break easily. They will not break easily. So these strong bonds are due to the carbon's small size. So this small size of carbon atom will enable the nuclei to hold the shared pair of electrons strongly between the atoms. So due to this strong bond, they are exceptionally stable. Carbon atoms are compounds are exceptionally stable due to the strong bonds. So let's see an example, like example octane. The octane formula is C8H18. So 1, 2, 3 carbon, 4, 5, 6, 7, 8. And hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So this long chain is, again, it shows the property of catenation. Carbon can form straight chain compounds, it can form branch chain compounds, and it can form cyclic compounds. So it can form straight chain compounds. So straight chain compound, just now we have seen for the octane. So it can form straight chain compounds, the catenation property of carbon in this, it can form straight chain compounds. The linkage will be maybe for the linkage will also be in the branch chain compounds also, carbon-carbon linkage. So the catenation property is also shown in the branch chain compounds also. Carbon is tetravalent as we know this. Then they can also form cyclic compounds. So cyclic compounds, or you can say they can also form ring chain or cyclic compounds. So cyclic compounds. So carbon is tetravalent. Suppose if all are hydrogen, then it is known as cyclobutane. This is cyclobutane. It can also form another ring chain compounds. Another example is hexagonal ring also. So these are tetravalent in nature. So these are the bonds. So hence the catenation in carbon, that is the self-linking of atoms to form chains or rings, is shown in the straight chain compounds. It is seen in the branch chain compounds. It is seen in the ring or the cyclic compounds also. So the compounds of carbon, if they are linked by CC single bond, then these compounds are known as saturated compounds, saturated organic compounds. These are, if they are linked by CC double bond, or if they are linked by CC triple bond. So these compounds are known as unsaturated organic compounds. Another example for catenation is starch and cellulose. This also shows catenation property. The general formula is C6H10O5N. Starch and cellulose, these organic compounds are polysaccharides which consists of linear chain of several hundred to many thousands of glucose units. So this starch cellulose shows catenation. Hence we can say carbon is the only element which exhibits maximum catenation, means maximum self-linkage property. No other element exhibits such a maximum catenation, such a self-linkage property. The next is the silicon. Silicon can make compounds with hydrogen which have chains up to 7 to 8 atoms, but these are very reactive. So if these are very reactive, means these are unstable. And the other elements which show catenation is sulfur and phosphorus. But they show catenation to very less extent. So these are the important properties of the carbon. That is why it makes large number of organic compounds. So let's have a quick recap. The versatile nature of carbon, why it can make large number of organic compounds. So it shows the covalent nature. Carbon has 4 electrons in the outermost orbit, so it is a tetravalent, and so it can form bonds by sharing of electrons. That is why it forms a covalent bond, and it has a unique property which is the self-linkage property. Carbon can link with another carbon, and they make long chains. That property is known as catenation. So due to all these properties, because of these property, it makes large number of organic compound, and all these properties make carbon a very versatile. Thank you very much.